If you want to learn how to build your very first agent, this video is for you. No coding skills required. By the end of this video, you will know the basics of AI agents and how to build your very own. No fluff, no complex setup, no computer science degree required. Let's go! Hey, Alex here with Grit AI Studio. Welcome to the first video in our Agent Build series, where we're covering everything from beginner basics to production-ready systems across multiple frameworks. You don't have to write the code yourself, and I will explain everything as we go through. I've been wanting to put together a comprehensive guide on agents for a while now, something for everyone wanting to learn. So this is a hands-on build series, and today we're starting with the Claude Agent SDK. I'm going to walk you through a progressive build, from the very basics of interacting with Claude, adding memory to our agent, equipping it with tools, and finally letting it run as an autonomous agent working towards goals that we give it independently. Each step adds one new concept. By step 4, you'll have a working agent, and if we have time, I'll show you how to add a simple user interface so that you can actually use it. This is your complete getting started guide to AI agents. Let's build! Before we start coding, let's get crystal clear on what we're actually building. Now, there are many definitions out there, and for some reason, people love discussing what an agent is or isn't. No, that's just an automation. No, that's an agentic workflow. Honestly, I don't think it matters that much what we call it. But I've generally found that this definition is quite useful in explaining it. An agent is an LLM with tools that runs in a loop. 3 components. That's the core concept. A brain with hands that runs in a loop. There seems to be somewhat consensus, at least around the concept of tools in a loop. An LLM agent runs tools in a loop to achieve a goal. As Simon Wilson also points out, the part about achieving a goal also means that there are not infinite loops. There is a stopping condition. In addition, we also assume some level of short-term memory to be able to work in more than one loop. Okay, so 3 key components plus memory. The LLM is the brain. Claude, Sonnet 4.5, GPT-5, Gemini, any large language model. It does reasoning, the planning, the decision-making. Tools are the hands. Tools let your AI interact with the real world. Search the web, read files, write code, call APIs, access databases for added context and to be able to act on our behalf. And by the way, the Model Context Protocol, or MCP, is widely adopted as our means to equip LLMs with tools. We have a whole video on that topic over here. So finally, the loop is what makes it autonomous. The agent runs in a cycle. Look at your goal, decide what to do next, use a tool or more, respond, check if the goal is complete, and if not, loop again. Now, our AI assistants today, like Claude or ChatGPT, they're definitely more agentic than they were just a year ago. They can access tools, search the web, analyze files, and even run code. Features like ChatGPT's deep research mode or Claude's ability to use special skills illustrates how systems are evolving beyond simple chat into goal-oriented agents that can gather information and take action autonomously. Agent mode in ChatGPT and the Atlas browser is clearly a sign of where we are heading. Here's the thing. Whether we're talking about a simple single-task agent that completes one research query or a fully autonomous long-running agent that manages complex workflows over hours or even days, the underlying principles are the same. Brain, tools in a loop. And honestly, the terminology debates, is this a workflow, an automation, an agent, don't really matter much in practice. What matters is, does it solve your problem? Does it save you time? Does it deliver value? Call it whatever you want. If an LLM with access to tools running in a loop helps you get work done, That's what matters. We're here to build useful systems, not argue about definitions. So, today, let's focus on building something real, with these 4 steps evolving from a simple Q&A agent to adding memory, equipping it with tools, and finally letting it run in a loop towards solving our goals. By the end, you'll see exactly how these 3 components come together to create something that can work independently. Now, there are several more advanced concepts that we'll cover in future videos, like persistent memory systems, guardrails, multi-agent collaboration, and so on. But today is all about the foundation: brain with tools in a loop. A year ago, if you wanted to build an AI agent using Claude or OpenAI's API, you had to do a lot of the plumbing yourself. You'd manually manage conversation state across multiple API calls, parse tool calling responses, implement the agent loop where a model calls tools and receive results, handle errors and retries, and build your own permission system to control what tools the agent could use. It was totally doable, but you'd write hundreds of lines of boilerplate before getting to the interesting stuff. And to be honest, you probably had to be a developer to do it. For some cases, you want direct API access. And if you're a developer, you might want complete control over all aspects. And that's fine. But for most of us, frameworks and SDKs help us build agents much quicker. I aim to cover a number of frameworks in this series, starting with the Claude Agent SDK. The SDK is a higher-level framework built on top of the Claude API, designed specifically for building intelligent, persistent agents. It's the same agent harness that Anthropic uses for Claude Code. We have the ultimate getting started guide to Claude Code here. The beauty is that with SDKs like the Claude Agent SDK, you get built-in conversation management, automatic tool calling loops, streaming responses, and standardized tool integration through protocols like MCP. Now, maybe those are some technical terms, but we'll get back to it. What used to take a weekend of infrastructure code now takes a few lines of code, so you can focus on building the agent's capabilities rather than reinventing the wheel. And here's the big one, the agent loop. With a basic API call, you get one query, one response, and done. But true agentic behavior means the model can think, I need more information to answer this, call a tool to get it, evaluate the result, maybe call another tool, and keep iterating until the task is complete. With the raw APIs, you'd have to build this loop yourself. Check if the model wants to use a tool, and then execute it. Feed it the result back, call the API again, repeat, and so on. You're manually orchestrating every step. With the SDK, it handles the entire loop for you. The model autonomously calls tools, processes results, and keeps going until it's satisfied or hits the turn limit. That's the difference between a simple chatbot and an agent that can actually do stuff. Over the course of this series, I intend to cover a number of frameworks for building agents. I'm not promising everything here, but there are several notable ones in the landscape that you can look at if you don't like the Claude Agent SDK. Such as AgentKit by OpenAI, which we've covered previously on the channel. And from the big players, we also have Google Agent Development Kit, or ADK, or the Microsoft Agent Framework, which plugs nicely with Microsoft Azure AI Foundry platform if you're on the Azure platform. Both ADK and Microsoft Agent Framework are open source frameworks. LangChain and LangGraph are popular open source options for LLM applications and agents. We have done a few build series videos in the past where we use LangChain. Then you also have Crew AI, which was specifically designed for multi-agent systems. And many more options in the low-code and no-code space as well. Let me show you what we're working with. As mentioned, the Claude Agent SDK was previously called Claude Code SDK, and is in fact the same agent harness that Anthropic uses for Claude Code, with all its power. At its core, the SDK gives us the primitives to build agents for whatever workflow we're trying to automate. It gives you everything needed for our 3 agent components: LLM, tools, in a loop. So let's start with the LLM. The SDK runs on top of the Anthropic API so that we get direct access to the brain, in this case, Claude. The SDK handles all the complexity: API calls, conversation management. You just focus on what you want to build or solve. Then we have the tools. The SDK provides a very easy way to define and equip our agent with tools. We'll come back to this in further details later on. And then lastly, the agentic loop. This is what makes it autonomous. Anthropic calls it the agentic loop, and it runs automatically in a specific feedback loop. Phase 1 is about gathering context. First, the agent examines your goal, reviews available tools, consider what it knows so far. Phase 2 is about taking action. Once the agent has gathered context, we want to give our agent flexible ways of taking action. Tools are the primary building blocks of execution for your agent. Tools are prominent in Claude's context window, making them the primary actions Claude will consider when deciding how to complete a task. We can define our own tools or make use of MCPs in addition to the built-in tools that Claude Code already offers. The agent picks a tool to use or decides it has enough information to respond. Claude Agent SDK also excels at code generation, which is also one potential action that the agent might use as part of the loop. And lastly, phase 3, verifying work. The Claude Code SDK finishes the agentic loop by evaluating its work. Agents that can check and improve their own output are fundamentally more reliable, they catch mistakes before they compound, self-correct when they drift, and get better as they iterate. The key to this part is giving Claude concrete ways to evaluate its work, both when we build agents, us being the one evaluating the output, and when the agent itself is running. And then, let's call it phase 4, is repeating. If the goal isn't met, the agent will loop back with new information. This continues until the agent determines that the task is complete. Now, without getting too technical, the SDK supports 2 interaction modes. Single message mode through the query feature. Here, we send an instruction that the agent runs and then returns the final result. And then we have continuous conversation or streaming mode through the Claude SDK client. This gives us the full agent experience with conversation memory, tool support, and so on. So 2 things jumped out for me when I started with this framework. First, how little code we actually need to get up and running. And second, how easy it is to define and expose tools to our agent. The real investment in any agent should be clear descriptions of tools, knowledge, and context, not the code. The clearer we describe what a tool does, the better decisions your agent makes. The clearer we describe the role of our agent in the system prompt, the better it will act on our behalf. All of this boils down to natural language and not code. Before we start coding, we need to set up an Anthropic account with Claude Code. Check out our entire Getting Started guide to Claude Code in the description below. Now that you have Claude Code ready, you can choose between the Python SDK or the TypeScript SDK. I'll use the Python SDK in this video for simplicity. For that, we obviously need Python installed, and then we can install the Claude Agent SDK. Open your terminal and type in pip install Claude Agent SDK. And that's it. Now you're ready. Now let's build this thing step by step. All right, here's our plan for today. 4 steps, each adding 1 new concept. Step 1, the foundation, a stateless agent that answers simple queries. Step 2, adding memory so that our agent becomes conversational and remembers context. And then step 3, adding tools to our agent. This way it can access real data and perform actions for us. And finally, step 4, adding our loop and turning it into an autonomous agent, letting our agent work towards a goal with the tools that it has available. We'll use a simple example of building an autonomous agent that can assist us in travel planning, but the building blocks and steps are the same for whatever you want to build. You could build a personal research assistant that gathers and synthesizes information, a customer support agent that handles inquiries and creates tickets, an email management system that drafts responses and prioritizes messages, or even a code review assistant that analyzes repositories and suggests improvements. The building blocks are the same. Okay, let's go. Let's start with the bare minimum, just talking to Claude. No memory, no tools, no loop, just 1 question and 1 answer. Okay, so let's start with the first step. We're going to fire up Claude Code in an empty project and run this prompt to build a simple trip planning agent. We'll start with the basic. In step 1, we'll simply ask Claude some travel planning questions and it'll give us answers. No memory, no conversation, just quick one-shot responses. Think of it like asking a travel expert individual questions without any context between them. Let's see what that looks like. We're building an agent using the Claude Agent SDK in Python. We'll do this in several steps, starting with a basic agent that responds to simple trip planning queries. We'll run this first prompt in plan mode and use UltraThink to let Claude Code properly plan it out and get the appropriate context. We'll get some clarifying questions before we can approve the plan and get to work. And of course, we also share the documentation for reference. Claude Code is an excellent example of an agent. It gets the goal from the user, then makes a plan. It uses a number of different tools, involves us to clarify, and then gets to work writing the code. It will test that things work, and if not, it will go back and fix the code, until it feels that it has completed the task at hand. Okay, so let's talk about what actually happens here. From the Claude Agent SDK, we're using the query function together with the Claude Agent options. Claude Agent options is where we define the settings of our agents. Most importantly, the system prompt that defines what kind of agent this is and what we expect it to do. Again, in plain English. This is also where we define the permissions for our agent. In this simple case, we're only going to do basic responses, so we set it to plan mode. Our super simple stateless agent is essentially this piece of code here, making use of the query function. That takes the query from the user as input together with our agent options. Then we simply loop over the messages that this produces and combine them into a response text that we return and print. Simple as that, just a few lines of code. We can ask Claude Code to run it for us. It will install requirements and set up the virtual environment for us. We can see the queries and the responses from the agent, or very simple chatbot at this stage, but it's working. The formatting is raw, but we can see all the output from the agent. That's pretty cool. At this stage, we will run a /init to create a Claude MD file based on our project so far, and then clear the context window before we proceed to the next step. Okay, so now let's expand on our agent functionality and add conversational trip planning with memory. Now Claude moves away from our stateless query approach from step 1 and instead turns our agent into a conversational agent using the Claude SDK client. It went through a few loops before it manages to finish this implementation, but it got there in the end. Claude Code actually tests the code for us here as well, and we can see parts of the conversation playing out on the screen here. Now, I want to mention that a trick is to actually load the entire docs into the project, as we can actually download the SDK docs as a markdown file that Claude Code can reference when needed. Okay, so first, let's go through the code here. The main difference here is that we've replaced our simple stateless query function with the stateful Claude SDK client. Then we simulate a multi-step conversation with the user asking several questions. We create our agent with the Claude SDK client and our agent options. And then we simulate multiple uses of the client query and client receive response functions. Our client holds memory of the conversation and will be able to answer a question based on prior knowledge from the conversation. Okay, so let's add some tools to our agent in the making. Let's say we want to check the weather and also organize our planning tasks into a little database. Now, this is just to show how easy it is to actually make your own tools, but you could equally connect to existing tools through MCP. Like for instance, your calendar, the Google Maps MCP for directions, or maybe Notion for organizing your travel plans. Let's try something like this just to demonstrate. Again, I will clear the context before we proceed. I'll be specific about what tools we want to add. I'll ask for a weather tool and point to the free and public service called yr.no. And I'll ask it to make a task management tool using SQLite, which is a lightweight, serverless, and self-contained relational database engine that Python has built-in support for. I'll answer these questions. Let's make things a bit interesting here. Okay. Let's go. Okay, there we go. It seems to be working from the test, but let's take it for a spin before we review the code. Let's make the output a bit prettier to read in our console. We'll just ask Claude Code to help us clean this up a bit. Now that's a lot better. This looks great. We can see it's using the tool and it remembers the context as we ask the next questions. This demo here is not really working, which is to be expected as the code generated some steps without knowing that our agent would actually ask a question back after the first step here. So let's just update this so that it makes a bit more sense for our demo. In the real world, you would of course talk to the agent and answer the questions yourselves. We'll get to that very soon. Claude changes the examples and also makes some adjustments to the system prompt here. Okay, there we go. Now it makes sense. And it's actually using the task management tools here as well, creating a bunch of tasks for us actually. All right, and then checking off tasks as well and giving us a status. Awesome. Let's have a look at the code for creating tools. This deserves a bit of attention. Again, you don't need to understand everything, but if you're a developer, this might be handy to understand. Okay, so we see we have two files here, tools and tools demo agents. So this is our agent, and let's start by looking at the actual tools that we create over here. So in this tools file, we can see that Claude has made use of the tool decorator from the Claude Agent SDK. And then it's setting up a little database with SQLite. Okay, it's actually making a list of locations because our weather API uses locations as coordinates. But here's the fun part. It's using this tool decorator to give the tool a name and a description. And then it describes the parameters that it's expecting. And then we have the logic of the actual tool, where you can see that it's taking the name of the city and then mapping it to the coordinates that we saw earlier in this file. Yeah, and then it's using the API to get the weather forecast for the next 7 days. And then it just formats the response into a nice 7-day weather forecast, which it then eventually returns in this JSON that our agent can make use of. This way of creating tools is actually really elegant. Then the second tool is to create tasks. So you can see that we create planning tasks for a trip. It's going to be making use of our database. It's going to take in some parameters and the same approach. All the logic that goes into the tool, it's making use of the SQLite database, and then, in this case, inserts a task. Similar tool for listing a task. We have the same approach for completing a task. And you can see that we also have a delete task down here. So that's about it. All of those tools are then imported into our agent. So in our agent, we can see that we'll just hide this for now. This was the formatting we asked for, by the way. Okay, we can see that we have our demo scenario number 1. So here we see we're still using the Claude Agent option with the system prompt, but we're now feeding in a list of MCP tools, which in this case is called travel tools. So this here creates an in-process MCP server that runs within our application. And in this case, it's got a name. Importantly, we also need to give it a version. And then we have the list of tools that we defined in the tools file. And then one important thing to note is that in order for our agent to actually be able to use them, we need to also list the tools unless we just accept all. But in this case, we're giving a list of tools. So here, the format is essentially MCP underscore, then the name of the MCP server from here, and then the name of the tool like this. And that's it. And then in this case, we're again just simulating a multi-turn conversation. We're using the Claude SDK client, which gives us memory, and we're essentially just feeding our options, which includes the MCP tools. The same for the other parts of our flow, just different examples. Again, both using the weather forecast and our task management tools. Tools essentially give our agents access to additional context when needed to solve a problem or achieving a goal, or to execute actions on our behalf. For instance, a weather tool provides real-time temperature data. A calendar tool checks your schedule and finds free slots. A file system tool reads documents or saves reports. But tools don't just retrieve information, they can act on your behalf. The same calendar tool can book meetings, an email tool can draft and send messages, a database tool can write records, not just query them. So when you say book a 30-minute meeting with John tomorrow at 2, well, Claude doesn't just tell you how to do it, it actually does it. It calls the booking tool, creates the meeting, and confirms that it's done. Each tool expands what the agent can actually do beyond generating text. So we'll dive deeper into MCPs in a future video, but it's worth pointing out as a side note that OAuth 2 MCP authentication in client is currently not supported. So any MCP that requires an OAuth flow, you'll need to work around this. But the SDK supports custom tools like we've demonstrated today, and you can also use external MCPs that use tokens for authentication. Let's take our agent to the next level, now that we have tools in tool demo agent Pi. Now let's make a fully autonomous trip planning agent that works towards goals independently, without asking questions. The user feeds in preferences, and the agent works through the tools available until goal is achieved. And then we'll just add that the user needs to input enough information at step 1 in the example. Claude outlines a plan for us and starts building our autonomous trip planning agent. We can see here that it's added some direction in the system prompt, telling it to not ask additional questions, make sure that it covers some steps. This is of course optional, and we can change that behavior later if we want to. Okay, actually, let's try asking for a slightly more autonomous approach and add web search here as well. Okay, now we see that the agent thinks and makes its plan, using a number of tools to collect context, then starts planning the trips by using our task management tools. And there we have it, a complete plan for our upcoming Euro trip. That's pretty cool. Let's look at the code. So we use the same components from the Claude Agent SDK here, the SDK client, agent options, and our create SDK MCP server function. We inject the same tools in addition to a new web search tool here. Then we have a couple of utility functions here for formatting the output messages, and this one to parse the trip planning input. Let's not worry too much about that. We create the MCP server for our tools, and then we have a comprehensive system prompt here, describing the tools, the key principles, and clearly stating that the agent shall work autonomously to achieve the goal from the user, to create a comprehensive travel plan. We even tell the agent to figure out the best approach and to be creative and adaptive in how it uses the available tools. We define the allowed tools and then just parse the user input with our helper function and then run our agent loop. Here we just use our format message function to write the output in a prettier way. And that's it. Okay, let's add a bonus step before we wrap up. We can now run our agent anytime that we want by typing Python and the name of the file in the command line. We can change the goal in the code so we have the foundation of an agent, but maybe not very intuitive and easy for day-to-day use. So let's see how easy it is to actually add a simple user interface so you can actually use this agent without running Python scripts every time. Let's spin up a simple user interface so that we can actually interact with our agent. There are many ways to do this, and we'll cover more in future episodes, but for now, let's make use of something very simple called Gradio. We'll just ask Claude to build this for us. Okay, I was thinking something simple, but why not? We might as well spice it up with some additional features. Export plan, a Kanban style task board, and a trip gallery. Okay, let's keep it simple for the rest here. Okay, let's try. Wow, it actually managed to one-shot this entire thing. One simple prompt, and it works. I didn't write a single line of code. Now you have a web interface, type your goal or questions, click run, watch it work. We can chat, ask questions, it has memory, and we can ask for a complete trip plan. That's pretty cool. If you want a command line version, just ask for that. It really is that straightforward once you're up and running with the Claude Agent SDK. All right, there we have it. A complete guide from zero to a fully autonomous AI agent with a powerful Claude Agent SDK. And we didn't write a single line of code ourselves. Let's recap what we've built. In step 1, we did simple queries, talk to Claude like a Q&A agent with no tools. Then in step 2, we moved over to the stateful Claude SDK client, giving us memory in our conversations. In step 3, we added custom tools, giving Claude access to real data and context. And in step 4, we tuned our system prompt into an autonomous agent that runs a loop until goal has been reached. And as a bonus, we added a user interface. Each step added one concept. By step 4, we had all 3 components working together, our LLM brain, tools for hands, and a loop for autonomy. This progression is how you should think about building any agent. Start simple, add capabilities one at a time, test each step. Don't try to build everything all at once. In future videos, we'll cover more frameworks and also more advanced concepts. And we'll definitely cover voice agents and multi-agent workflows as well. So make sure you hit that like button and subscribe to not miss out. After watching this, I really hope you go away and build your own agents and experiment. Change the system prompt, change the tools, try different goals. Break it, fix it, experiment. The best way to learn agents is to build them yourselves. I hope you found this video helpful. If you build something interesting, I genuinely want to see it. Let me know in the comments below. Thanks a lot for watching, and I'll see you in the next one.